playing the music. All right. Good morning. Good evening first, I guess. Good evening, good afternoon, good morning. Thank you all for joining. A lot of people. Can you type where are you guys joining from? All of you. We
Wow.
will. Yeah. Qatar. I know Avinas from Johor.
No, I'm joining in
Uh,
from Singapore.
India. London.
Wow.
Chennai. Wow. Yeah, man. Wow. Wow. Egypt, Netherlands. All right. Thank you for joining. All right. I think today is a very special episode of our webinar, right? Typically, I deliver the webinar alone, but now actually I have my friend Avinash also with me, right?
Yep.
Okay, let's get started. Okay. So the title is the necessity of rigorous model for a rigorous separator model, right? Integrating Aspen HYSYS with MySep engine, right? So two of us will deliver this webinar. I'm with Avinash, business development manager from MySep, right? So let's get started. Right. Okay. So just for your informations, we do have scheduled a few upcoming session also. So 6 June we'll have blowdown, HYSYS blowdown with a case study. I will also be delivering this with Viresh Sharma, right? And on the 20th June, I will have a talk. This is probably will be organized in LinkedIn Live, right? So I've asked my friend Jonathan Ayala to talk about his work on as a scale up engineer, right? So again, on the 2nd of July, I'm also asking Jonathan to actually talk about direct air capture technology, right? So this is things which is coming in the next few weeks, right? So if you are interested, do register, right? All right, so let's get through the introductions. I think this is me. Some of you, maybe you have attended a few webinars or sharing sessions already. I'm a chemical engineering, right? A bachelor, not doctor. From Indonesia. I graduated from Institute Teknologi Bandung in Indonesia, right? And I worked for 4 years there, and I moved to Singapore while I was with EPC company, upstream EPC company, McDermott. I did my MBA in NUS in 2014, right? Then, yeah, I've moved to Wally, doing a lot of more of front end work, the feed, right? Regasification, refinery, and some chemicals, and also working in their consulting arm at Visions, doing front end due diligence, financial modeling, right? Then I joined for a while with FOPAC, operating company, mainly operating terminals, right? Oil and chemical terminals. Now I'm with, since 2019, I'm with Aspentech, right? So I will introduce my friend. Sorry, disclaimer first, right? This is my personal disclaimer. Basically, for me, I'm speaking as my personal capacity, right? I'm not representing my current or past employer, right? All the view I stated here is basically based on my personal view or industrial experience, right? Which is may or may not be supported by my current or my past employer, right? So this is my personal, right? Because right now I'm going to I'm going to introduce my friend Avinash Ravendra, right? Uh,
Yep.
Avinash is the business development manager at MySep Private Limited, right? At his current role, he's focused on strengthening the presence of the MySep in the Asia Pacific region, right? Covering sales as well as software support activities. He has over 5 years experience in wide spectrum of in the energy industry, covering both upstream and downstream verticals, right? In the past, he has led a sales team that was responsible for an array of simulation studies, right? Bespoke engineering solutions and operator training simulations, right? Okay, welcome Avinash to this
you.
webinar, and thank you for having thank you for sharing your knowledge also
No,
with this.
thank you, Fauzi, for the kind introduction and for having me on board of the session. Really looking forward to sharing and speaking with the rest here today.
All right. Okay. Okay. Just housekeeping. So we do have a chat windows. If you want to type, but if you have a questions, please do go to the Q&A tab there. You can go to the Q&A and type your questions, right? Right. And also, okay, let me handout. Sorry, I'm going to upload the handout in few minutes, right? But you can click this like a document icon at the far right, right? That's to download the handout, right? This slide deck which we are presenting. Okay. All right. So today's agenda, we will start with. I will start with a little bit of how you model a separator in HYSYS, right? Then I will hand it over the hard part, the important part to Avinash, right? He will start with talking what's the value of rigorous modeling using rigorous separator modeling using MySep, right? And how does it work, right? And how you what actually you can do with the tools, right? MySep Studio and MySep Engine, right? So we will demonstrate two workflow. One is the workflow using the MySep Studio by Avinash, right? So Avinash will demonstrate that part. Then he will pass the file and hand it over for me to just show you how to take Avina's work, the separator informations he has done in MySep Studio and incorporate it in HYSYS, right? So this is our agenda for tonight, right? All right, so this is very brief. I think in the separator model, in HYSYS, you can do a carryover, right? By default, the carryover model is none, means it's ideal separations, right? There's no liquid getting carried in the gas phase. There's no uh, uh, heavy liquid in the light liquid phase carryover and vice versa, right? And then you can, this is the first part, right? First options. The second options is basically we specify using fractions, right? How much of the feed is getting carried over, right? Or we can use it in this either feed basis or product basis, right? We can define. So this is more of material balance purpose, right? This is not predictive. The split or whatever the fractions is remain constant, right? Regardless of what the operation condition change, the flow rate changed, right? It will not change these fractions or these definitions of fractions, right? So that's option two, right? And the option three is basically a carryover, correlation based carryover calculations, right? So HYSYS has a few built-in, right? Tonight we're going to talk more about the correlations from MySep, right? All right. So I will hand it over to Avinash. I will stop sharing. I will
Okay,
take off my video.
cool. Let's get this into presentation mode. Okay. Fauzi, can you confirm if you can see my screen? Fauzi, can you hear me?
Yes, I can see your screen.
Okay, perfect. Just wanted to make sure everything's okay. Cool. Just picking up from what Fauzi had left off. I think one of the areas where you can use MySep within HYSYS is by integrating the rigorous MySep models within HYSYS. But before we go into the actual workflow and what it is, I think I'd just like to explain what are rigorous MySep separators and what they do before we look into the demo itself. So let me just get my laser pointer. Um, Rigorous MySep separators are basically separators that are modeled with respect to the vessel dimensions as well as the vessel geometry. So this is typically done within the MySep Studio software. And what you can do within the MySep Studio software is that you can model both two-phase and three-phase separators, horizontal and vertical, and you can model all the different types of implants that you may have. So this includes the different types of inlet devices, different types of demisting devices, as well as liquid-liquid separation technologies such as split pyrolysis. So that's what you can do within the MySep Studio software. So this diagram here depicts what a rigorous separator would look like. What the MySep Studio software produces as an output is separation performance. So separation performance is something that the MySep Studio software calculates for you. So this includes gas-liquid separation performance, liquid-liquid separation performance, as well as liquid-solid separation performance. So the MySep software predicts liquid carryover with your gas stream, water and oil and water content, as well as sand separation. So that's what the MySep software predicts. And like what Fauzi had mentioned before, the models that we built within the MySep Studio environment can be integrated within HYSYS. So this is something that MySep Studio brings to HYSYS. So this brings the rigorous gas liquid separation that we have within the MySep Studio environment into the HYSYS flowsheet simulation. So that's a very brief background of what rigorous MySep separators are and what they do. I think what would be more interesting to you guys is that what can you now do with this integration? I think first and foremost, the MySep engine integration, what it does to your flowsheet simulation is that it makes it more rigorous, it makes it more representative of what you see in the field because idle separation is far from reality, it's far from what happens in the field. So having MySep there helps you bridge the gap between what you see in the field and what you see within the simulation environment. So it makes it much more representative. Second is that it does not only bring the gas liquid separation performance into the flow sheet, but it also tells you what are the limits within your separator. So if you're changing operating conditions, MySep will actively flag what kind of limits are being breached with respect to the separator. So this could be very simple things like inlet momentums, velocities, or it could be things that are very much concerned on the performance of the separator itself. So it will flag things like breaching the listing devices key value and things like that. So it will give you an idea whether you're within the safe operating limits or not. So what can you do with this much more rigorous models? I think it adds way more confidence when you're doing troubleshooting and root cause failure analysis. Once you have a representative model, it becomes much easier for you to do a detailed root cause failure analysis. You can understand whether the performance degradation within your compressors are caused by malforming separators. You can identify whether foaming in your contactors are caused by liquid carryover from upstream separators. So it helps your troubleshooting and root cause failure analysis. Second, it also helps you do debottlenecking or throughput increase assessments. So this is very useful because with the MySep engine integration, you can understand what are the limits and what are the potential effects to your overall flow sheet when these limits are being reached. And we also see clients using MySep more proactively for things like performance monitoring. So they plot operating envelopes through this integration. And we also see clients linking blood data to actively trend liquid carryover parameters where it may be of interest. So this are just some examples of how MySep is being used and how the integration with HYSYS is adding value to our clients. So I think in the first bit, we've spoken a little bit about what MySep hero separators are, and what and how they add value to the overall flowsheet simulation. I think the next slide, I'm just going to give you a little bit of idea of how MySep does the performance prediction. I think this is maybe of interest to all of you. MySep works on a proprietary modeling approach. We call this the MySep incremental modeling. I thought it would be best to explain this to you with an example. So I have a sample separator here. This is a typical three-phase production separator that you would see in an upstream facility. So I have my upstream piping, I have my inlet device. In this case, I have a vein type inlet device. I have a demisting device here. It's a vein pack demisting device, and I have distribution baffles on my liquid side. So how MySep makes the performance predictions is that it first starts at the inlet piping. So what MySep will do is that it will take a look at what goes on within the inlet piping, and it will actively quantify two parameters: the droplet sizes that you're getting into your vessel, and also the amount of liquid that you're entraining in the form of mist. So droplet size distribution and mist fraction is a prediction that MySep makes. So this is very important because this determines how easy or how difficult your separation problem is going to be. So that's what MySep defines as a start point within your vessel. So this is the first definition, the first prediction that we get within the MySep environment. And then it takes a look at what goes on within your inlet section. Depending on the type of inlet device that you select, MySep will quantify a mist removal efficiency. In this case, a vein type inlet device does not contribute much to mist separation. So you see that your mist separation is zero. So all of the mist that you generated within the inlet piping will be sent to your gravity section. So at your gravity section, we'll do another performance computation to figure out what are the droplets that are going to be separated by gravity and what are going to be remaining entrained to the next stage. So here we'll again define what is the outgoing droplet size distribution. This outgoing droplet size distribution will then serve as an input for your demisting device. So again, iteratively in the demisting section, we will quantify based on the definition of your demisting device, what is the mist droplets that can be removed. So I think to put more context to this, what we were getting in were roughly in the range of 1000 microns. In our gravity sections, we were capable of removing droplets of 150 microns or bigger. So anything smaller than 150 microns was carried over to your demisting section. At the demisting section, we were capable of removing droplets of 50 microns. So in a nutshell, what I think I wanted to explain is that what MySep does is that it takes a look at each of the section of the vessel in detail and then incrementally quantifies what is being removed at each section before quantifying the overall separation performance. So that's what MySep does to predict gas liquid separation performance. It does something similar for the liquid liquid bit as well. So this is just to give you an idea of how MySep works. And I think you will see this once we go into the demonstration itself, and we can take a look at that in further detail. So before we jump into the demo itself, like what Fauzi mentioned, we're going to be looking at two things. The first workflow is going to be taking a look at individual separators within the MySep Studio software. And the second approach is going to be taking a look at integrating that various models into HYSYS. So I thought it'd be a good idea to give you an idea of what each of the individual models do so that you have a better and a clearer picture once we go into the demo. So the first application is called MySep Studio. So what you can do within the MySep Studio application is that you can read and design individual separators. So it lets you take a look at all the detailed sections within the vessel, and it will quantify the vessel performance as what we saw earlier. So if in the area of designing a vessel, it has a lot more features. It helps you do automatic vessel sizing. It also computes the vessel weight within the software environment. If you're on a floating facility, it has capability to quantify motion effects. And if you're integrating into more brownfield operations, it produces an operating envelope. So it tells you at which range, which operating point you'll be suffering from carryover. So it plots the carryover curves. And it also has a lot of other features that helps design as well as brownfield works, such as data sheet and report generation. So that's what MySep Studio does. It helps you build the geometry, it helps you design as well as rate separators that are existing in the field. And it also has bidirectional linking to most of the leading simulators as well as HYSYS. So what you can do is that if you have a separator that you like to model, you can pull in the process data into MySep. You can do the performance computations within the MySep environment, and you can overwrite the results back into your flow sheet. So that's what MySep Studio is capable of doing with regards to simulator communications. I'll demonstrate that to you when we go through the demo. But in a nutshell, what you need to remember is that the MySep Studio application is where you model the separator in detail. The second application is called MySep Engine. So what MySep Engine is pretty much a runtime. And what this runtime engine lets you do is that it lets you integrate the rigorous model that you built in Studio within the HYSYS simulation environment. So it brings the rigorous gas liquid performance computations within the HYSYS environment. And whenever you make a change within the HYSYS environment, the separator object no longer uses, like what Fauzi mentioned earlier, the ideal separation or carryover based specification, but it uses the correlations that MySep has built. So this works on both steady state as well as dynamic mode. So that is with respect to the MySep Studio and MySep Engine and what it does. I think it'll give you a clearer picture once we go into the demo itself. So yeah, let's look at the interesting part, the workflow itself. Let me launch my simulations. Okay, I'll minimize this. Okay. Fauzi, can you just confirm if you can see my HYSYS screen, if everything is coming through well?
Yeah, I can see that. Yeah.
Cool, cool. Okay, in this case, what we're going to be looking at is we're going to be looking at an existing production facility. What I have here is a typical upstream production facility. I have two assets flowing. I have one asset, one group of wells connected to my facility. One is not. And within this model, what I have is I have a three-phase production separator. I can use my first stage separator. I've truncated the condi as well as the water stabilization system. And what you're seeing here is the gas compression system. So within the gas compression system, I have two suction scrubbers. So on the first bit, what we're going to be looking at is we're going to be looking at modeling the separators rigorously within the MySep Studio application. I'll most likely show you how we'll analyze one of the separators. And on the second bit, we'll take a look at the workflow of having that separators that we've built within Studio integrated within HYSYS. This is where Fauzi would talk to you a little bit more of that integration. So let me just pull up my MySep Studio application. So this is how MySep Studio looks like. So within this MySep Studio model, what I have is I have three separators like what we saw earlier. I have my first stage separator. So my first stage separator is a vessel that looks like this. So what I have within my first stage separator is a vessel that is 9.5 meters in length, 2.8 meters in diameter. It has a vane type inlet device, has a vane pack demister, and I have two distribution baffles on my liquid side. So this is the definition of my first stage separator. Let's just have a quick look at my first stage scrubber. This is how my first stage scrubber looks like. I have a vane type inlet device and a vane pack demisting device. And this is how my second stage scrubber looks like. I think it shares a very similar configuration. It just varies in terms of dimensions. So this also has a vane type inlet device and a vane pack demisting device. What I'm going to do is that I'm going to just walk you through one of the separators. I think the best case would be the production separator. So let's just go through that in detail. So this is a model that I've already built. So I'll just walk you through very briefly of the model construction methodology, then we'll take a look at the analysis itself. So for me to reach to this point of having this model, I have to go through a couple of steps. Typically, I'll start at the configuration. This is where I define the geometry of the vessel. So I choose whether it's a horizontal or vertical vessel, what type of separation it has, whether it's a two-phase separator or a three-phase separator. In this case, it's a three-phase separator. I define my vessel dimensions, my diameter and my length, the head type, whether it has a weir and other configurations such as split flow or liquid pool. So once I go through this, what I'll get is I'll get a definition of my vessel shell. So that is defined. And then I will look into the rest of the sections. So I'll take a look at my inlet piping definition. So this is where I define my pipe size and my pipe area. These two parameters are quite important because they impair your droplet size distribution and misfraction. At my inlet section is where I select my inlet devices. So in this case, I have a vane type inlet device. But in MySep, you can also model different types of inlet devices. You can model cyclones, vents, hub pipes, or pipes, or diameters. So all of this are available. This is where I define more details with regards to my inlet device. Liquid levels is where I specify my set points. In this case, because it's a rating exercise, I've already specified my set points, and MySep will calculate the residence times and the volumes based on the set points that I've defined. Liquid section is where I define my distribution vessels. If you remember from before, I had two distribution vessels. This is where I specify them, and these are all the parameters in regards to the vessels. I'm going to skip solids. Gas section is where I specify my separation length. This impairs the separation performance calculation. So this is something that you need to specify, or if you're in a design case, MySep calculates this for you. And finally, the domestic device, where this is where you select whether you have a mesh pad, paint pack, or cyclone. These are the types of things this MySep can model. So once you go through this iterative process, what you'll get is you'll get a vessel that looks like this with respect to the intervals configuration. So this is a rating workflow. If you're doing a design workflow, it's a bit more different. Like I said before, you have an auto size feature, and MySep will automatically come up with the dimensions of the vessel once you select the type of intervals you'd like to have. So that's sort of the model construction methodology in MySep. I think the next bit we'll take a look at analysis. So for MySep to do the performance predictions, you need to get some process data in. So MySep needs parameters like pressures and temperature, as well as the physical properties for all of the individual phases, the gas, hydrocarbon, liquid, and water. There's a few ways you can do this. You can punch these parameters in manually. You can get it in from an Excel or from a simulator. So in this case, I'm just going to connect to my HYSYS simulation. Connect to HYSYS. What it will do is that it will just pick up the simulation case and it will identify all the separator unit op. So I'm just going to pull in my stream data from my first stage separator. So select first stage separator, click case one, get data. What MySep does is that it goes into the simulation case and it interrogates stream tree and gets the stream tree properties into MySep Studio. So now if I go back to project and as I look at my process data, you can see my process data is updated. My vessel, my production separator is operating at 10 bar gauge. I'm getting roughly 110 million scf of gas coming in. Hydrocarbon liquid is in the range of 68,000 barrels of oil coming in, and I have 25,000 barrels of water coming in. So that is my process condition for the case that is imported. So if I click on first stage separator and if I click on summary, what MySep will do is that MySep will give me the performance results for this vessel. So this is both gas liquid and liquid liquid separation performance. Perhaps we'll focus on the gas liquid bit first. So what MySep tells me is that for the current operating condition with the current vessel configuration that I have, I can remove droplets of 54 microns or bigger. Anything smaller than 54 microns will be carried over to my subsequent vessel. And in absolute number, that corresponds to 797 liters in ratios, that is 4.56 US gallons per minute scarf. And the vessel separation efficiency is roughly 99%. So that's what MySep tells me on the gas liquid bit. On the liquid liquid bit, MySep quantifies the residence time for both oil and water, and it also quantifies what kind of droplets that I can remove both from my water layer as well as my oil layer. So this is the predictions, this is the results of MySep. But like what I've explained to you earlier, it goes through an iterative process to reach this endpoint. So I guess it'd be beneficial to walk through that. So let's take a look at what goes on first within our inlet piping. So at my inlet piping, what MySep does is that it takes a look at my inlet pipe size and my inlet pipe ID, and it quantifies what is the droplets that is coming into my vessel. So in this case, MySep tells me the biggest droplets, mist droplets that's coming into my vessel is going to be in the range of 1056 microns. So that's going to be the biggest droplets. I'm also going to get smaller sized mist coming into my vessel. So in the range of 500 microns, I have 75% of my droplets in the range of 500 microns. So this gives me an idea of what is coming into my vessel. It also quantifies what is this amount of liquid that is entering the mist. So that's roughly 4.5% of liquid in the form of mist, and that corresponds to roughly 27 meter cubes of mist coming into my vessel. So this defines my separation problem at first. Maybe I'll just show you another case for comparison. I will add another case. I'm going to use this neat flow multiplier that MySep has. I'm going to do this 110%. What I'm doing is that I'm just copying case 1 into case 2 with a flow multiplier of 10%. So it increases my gas, liquid, and water flow rate by 10%. And what I intended to show you is that the impact of increasing flow rate by 10%. So by increasing flow rate by 10%, what MySep tells me is that the droplets coming into my vessel are going to be much smaller. I'm going to reduce my droplet size distribution to 950 microns. And my mist fraction goes up by almost twice the amount. So from 4.5% to 7.5%. Mist flow rate goes up from 27 meter cubes to 51 meter cubes. So it clearly shows us that for case 1 with 10% more flow rate, separation condition becomes more demanding. It becomes more difficult for the separator to separate gases and liquid. You can also see here that the carryover went up from 4.5 to 9.5 US gallons per minute scarf. So that's something MySep can easily show you for 15 cases. So that's what MySep predicts on the inlet piping section. Let's move on to the inlet section. So the inlet section, what MySep does is that it takes a look at things like device momentums, and if you're breaching momentums, MySep will flag a warning. So for vane type inlet device in MySep, 9,000 is the limit. So we are still way below the limit, so we're doing good. And here you would actually see the device D100 removal is 0 microns. So in this case, it tells you that this device does not contribute to any mist separation. So all of the mist that is generated within your inlet piping, 27 meter cubes for case 1 and 51 meter cubes for case 2, the 110% case, is brought over to your gas section. So let's take a look at what goes on within the gas section. Oops, that didn't work out quite well. Okay, maybe I'll put this as inlet piping. So from our inlet piping, we know this is the droplet size distribution that's coming in. MySep does a computation for my gas section based on my separation length as well as my meter space heights and velocities. It tells me for case 1, I can remove droplets of 150 microns. For case 2, which is the 110% case, I can remove droplets of 164 microns. So any droplets bigger than this, they will be removed by gravity. Any droplets that are smaller than this, they will be carried over to the next section, which is my domestic section. So this gravity section contributes to roughly 91 or 95% of separation efficiency. So 95% out of what we had here, 27 meter cubes will be separated. The remaining 5% will be carried over to my demisting section. So 1.4 meter cubes will be the inlet to my demisting section. So here MySep also graphically represents the outgoing droplet size distribution. So 150 microns will serve as the inlet for the demisting section. So now let's take a look at what goes on within the demisting section. So the demisting section, let's put my gas section here. So at the demisting section, I have a vane pack. This is the flow area of the vane pack that I have defined, and these are other parameters with regards to the vane pack. So MySep will compute the operating K value, and it also identify the flooding point K value. So if you're breaching this limit, your separation efficiency might reduce very well. So in this case, we are still within the flooding point K value limit. And MySep tells me that I can remove droplets that range from 51 microns to 54 microns between case 1 and 2. So from the 150 microns that was coming in, I can remove droplets of 50 microns. So all of this section is removed. Anything below than this, which is going to be the outgoing droplet size, will be carried over. So that's how we quantified the separation performance that we saw earlier. 54 microns for case 1, 51 microns for case 2. That's with regards to droplet size. It also quantify what is the carryover rate in absolute numbers and in ratios. Here, MySep also gives you an idea of how graphically the results, the separation efficiency, the carryover per stage, how much to carry over from individual stages, the droplet size distribution as you saw earlier. So that's what MySep does in a nutshell with regards to the gas liquid separation. I'm going to push on and show you how MySep handles the liquid-liquid separation bit. So earlier we had a brief look at the liquid levels. So the liquid levels here, they will contribute to two things. It will contribute to the control residence time. So this is computed between each level as well as the volumes. This will then be used for the liquid-liquid separation performance. So here at the liquid section, this is what we saw earlier. This is the definition of the baffles. But here you can actually see the degassing efficiencies. So MySep will contribute will quantify what is the water and the hydrocarbon liquid degassing efficiencies. And if you go into the liquid section, MySep will take a look at the separation length for both your hydrocarbon liquid as well as your water layer. And it will quantify what kind of water droplets as what kind of oil droplets that you can remove. So in this case, for case one, let's just focus on case one. For case one, we have a residence time of roughly 2 minutes. And with that residence time, we can remove droplets of 577 microns. For my water layer, I have much bigger residence time. I have roughly 4.67 minutes, and that helps me remove much smaller droplets. I can remove droplets of 177 microns. So that's what MySep does in the liquid bit. It also does something more detailed. When you look into detailed liquid section, what MySep will do is that it will quantify the droplet sizes. So in this case, what MySep is telling me is that the dispersed phase droplets that enter my vessel are in the range of 1,500 microns. So in this case, because my vessel is hydrocarbon liquid continuous, what this number means is this is the size of the water droplets that is coming into my vessel. So the size of the water droplet coming into my vessel is 1,526 microns. And from my separation calculation earlier, I know that I can remove water droplets that are in the range of 577 microns or bigger. So MySep will do a very similar calculation to what it did with regards to the gas liquid separation and quantify what is the amount that remains in drain and what is the amount that will be carried over. So when we can remove droplets of 577 microns or bigger from 1,526, it corresponds to a carryover of 7% of water and hydrocarbon liquid. So that's what MySep can do with respect to detailed liquid separation. So it will quantify both in terms of absolute numbers, in terms of carryover, as well as ratios and ppm levels. So here you can see what is coming into our vessel. For the first case, 1,500 microns were coming in, and we were able to separate droplets of 577 microns or bigger. So the remaining amount will be the ones that will be carried over at my hydrocarbon liquid outlet. That's going to be the water that's going to be carried over in my hydrocarbon liquid outlet. So that's what MySep does with respect to liquid separation.
Avinash?
Yep. Go ahead.
There's a questions related to this liquid from Muhammad Umar.
Okay, let me take a look at the questions.
Yep, I can read it to you. Just to confirm,
Okay, go ahead.
Can predict in liquid carryover with the same accuracy you can do in liquid in vapor. I guess yeah, it's asking the liquid separations carryover calculations is the same accuracy with the liquid in gas or vapor calculation.
Yep. So what MySep does is that it assumes that you have even flow distribution in the piping. So what it do is that it will use that assumption and it will take a look at your process condition and it will quantify what you have coming into your vessel. So in this case, if you have good flow distribution in upstream piping, this is what your droplet sizes will be. But for example, if you have flow restriction devices upstream, so in this case, if I have a valve, I can represent the valve and the MySep will sort of account for the distribution of the disturbance that the valve will introduce. So in this case, this is a very quick demo. So the valve is located 10 meters upstream. And if the valve has a pressure drop of 1 bar, we can see that the valve actually shears the droplets into much smaller droplets. And you will see that MySep uses the new droplet size distribution for the predictions. And you can see that the separation performance reduces because of the changes in the droplet size distribution. So yes, it can account for things that are upstream of the vessel in terms of flow disturbances.
All right, thank you.
Yep. Fauzi, any other questions that we need to address?
I think the rest we can address it later. It's okay. Yeah.
Okay. Perfect. I think in a nutshell, if we want to cover how MySep does the predictions, I think that's pretty much what I've showed you. There's a lot more things that MySep can do, but I think we'll save that for another day. So to summarize what we've seen so far is that we've seen how MySep will handle the gas liquid separation performance, how it incrementally quantifies what comes into the vessel, what gets separated at the inlet section, gravity section, as well as the domestic section for quantifying the overall vessel performance. We've also looked at the same for the gas liquid separation section. So in the next bit, I think what Fauzi and I intend to cover is that how do you actually integrate this model into HYSYS or into a process simulator. So for that, what you need to do is that you need to export the geometries that you've built. So which means I need to export the definitions that I've made within my MySep Studio model into a file that can be consumed by HYSYS. So that is done in a very simple step. If I go to Tools, if I go to Simulator Communications, remember this is where I got my process data in, would actually see that I can generate something called an engine geometry file. So I need to generate this file, which will serve as an input to my HYSYS simulation case. So I hit on generate, it will generate something called an MYG file. So what this MYG file is pretty much a definition of the vessel, the dimensions, your internals definition, what kind of internals you have, what are the parameters of the internals. All of this are packaged in a format where HYSYS can read and HYSYS can use it to predict performance. So this will then serve as an input for the HYSYS simulation and for the MySep engine extension to work within HYSYS. With that, I think I will pass it over back to you, Fauzi, for you to show how we can use this geometry file and integrate the model within HYSYS. So over to you,
Right.
Fauzi.
Thank you. Give me one sec. Let me share my screen. All right. Okay. Yep. So I'm using the same file as what Avinash is using, right? And we have here the file which already exported by Avinash using the MySep Studio. This file contains the informations of the geometry of each of the separators in that in this facility, right? So how do we bring that, right? So I think there's just to step back also, right? Why we want to do this, right? Because sometimes we actually want uh, to predict the actual performance of equipment. In this case, is separator, right? Last time we talked about heat exchanger, how we incorporate heat exchangers geometry. Now, basically, we are incorporating the geometry of the separator, right? By modeling that, we will know what's the impact to the other equipment, to the downstream equipment, right? The performance, right? So how we bring that? So I'm bringing my palette. I've already, so I can search MySep here. There's a MySep. I can put this, let's say here, right? I can name it this, let's say separators, right? I'm going to bring the geometry files, right? This is the geometry files. Okay, so you can see here on the left is basically listing all the unit operations, the separator unit operations in my HYSYS file, right? There are three, and Avinash already created three geometry details also in this file, right? So what we need to do next is basically we need to match this uh, to the mapping, right? So this unit operations will take these geometry files, right? Then same with this, right? And next is this, right? Okay, so right, so you can see here currently the MySep, sorry, the carryover model is using none, right? The kind of ideal separations, right? Now we're going to activate the correlations from MySep, right? So this is the first stage separators. So if I activate this, right? So let me, okay, so it will shift to this correlation base. Now it's using the MySep carryover, right? So we can view the, for example, here in the design tab, the informations of the geometry which has been defined by Avinash here, right? The inlet piping, the diameters, the length, right? The type of the inlet device, including input for the set points, right? For the level set points, right? In the calculations result, you can also see I've activated one. So we have here the inlet and the separations for the inlet piping, inlet device, the gravity sections, right? Include and the demisters, right? So I will activate now the rest of that calculations for the other two, right? Okay, so you can also access, so you, for the carryover, you can also go to individual separator here. You can click the few correlations. The same here, you can see the results, right? Same. And you can see if there's any warning, it will actually present it in this, right? You can see what warning, right? What type of warning is there, right? Okay. Same here. Right. Okay. So next, basically, we can also like production sometimes changes, right? So sometimes you might need to bring additional well to the facility, right? To increase the productions or to make up some productions on the other facility, right? So let's say we want to or even sometimes we want to connect, right? So like for example, there's a nearby well you're exploring. Now we need to check whether we can uh, handle the additional well fluid, right? How is the impact to the unit operations on this additional well fluid, right? So we have this additional well fluid, right, from asset 2. We're going to connect, right? So here is the summary of the current state, right? I think I've captured that here. Let me check. Right now I can capture. All right. So now let's say if we connect this, right? So you can see now it will calculate based on the separations, right? Based on the correlations, what's the impact on the different separator, right? So for example, essentially this the load increase, right? So you can see the carryover, roughly most of it will increase, right? Yeah, all of it will increase, right? Okay, of course we can also do a case study if you want, like do a sensitivity study of the, let's say, this well fluid, right, varying the certain flow rate of the gas, for example, and see the impact of the carryover, the droplet size, right? We can do that. So we can let me map this first, right? So for example, droplet size of this first separator, right? So let's say which one?
Yeah, you can take a look at the demister one. Perhaps that would be the most representative one.
The demister one, yeah?
Yeah,
Yep.
yeah. So that's the droplets that, yeah, the vessel can remove.
Separator, right? So I can drag and drop it here, right? Then
Yeah.
I can do the same for this. This is 301. Okay, this one. Right then I can do the same for here. Okay. Right. So I'm going to connect that. I will leave the warning. It's okay. Right. So I can do a case study here. I can go to case study. I think Alvina says set up something. Then I can. So this is the varying variable, the independent, the dependent variable. I can just drag this. Right. This is all the carryover value. Right. And this is the droplet size. Right. Okay, so I can set up this. Has been set up from 8,000 to 60,000, increment of 2,000 kilogram per hours, right? Then I can run this case study. Right, so I can go to the results. Probably I will transpose this, right? So I can see for different, this is the flow rate, and this is my first separator, suction scrubber, LP suction scrubber, MP carryover, and this is the diameters, right? So the droplet size, right? So we can take a look here at what, let's say, at what increase in flow rate we can tolerate depending on the criteria, right? So that's the case study, right? Let me go back to the slide. Right, I think something which I want to bring, let me make sure that I've covered, right? And we've talked about this, generating the files, and basically we're switching on the MySep carryover correlations, right? We load the geometry files, do the mapping, and activate the correlations. Then we can get the calculations, right? Calculation result. Right, so the other things which I want to also highlight, so this is can be used also for definitely for designing, right? Designing your separator, or maybe troubleshooting, your assessing your separator performance. So the other things also, we can also use this for performance monitoring, equipment monitoring, right? So in the sense that, for example, there's no instrumentations to actually measure your carryover, right? But this value is actually calculated by the model, right? And this value probably give you indications whether they're going to be an issue, let's say, to your downstream equipment, to your compressors, right? So you can actually bring your value, you can bring your data, for example, from your historian with the flow rate, etc., right? You can send it to HYSYS. HYSYS will, with the engine MySep engine, will calculate the droplet size, the carryover, and actually it can write back to your historian, and it can display that in a dashboard real time, right? So that to actually give an alert to no operators, to give you indications, right? So this is something you can provide or develop for, especially for operating company, right? So for to have equipment or separation monitoring, right? Okay, I think that's about it. Maybe you want to cover this quickly. Yeah, so I think we have.
Sure.
Yeah, go ahead.
Yeah, go ahead, Fauzi.
Yeah, I think we have covered the how to build the model rigorous separator, including like the dimensions, the of the different inlet device, the outlet device, right? To incorporate that, the rating workflow in MySep Studio, as well as how to incorporate that details back into HYSYS, right? Okay. All right, so let's go through some questions and answer. I think let
Yeah,
me
let's do that.
yes. Right. So let me go from. I think some of that. Okay. The other thing. One is this questions from Mohammed Yasser about correlation. What kind of correlation used for the separator sizing calculations in MySet?
Yeah, that's a very good question. So what we use in MySep is correlations that we have tested and validated in our very own lab. So we have a lab in the Netherlands where we test a lot of different types of internals and a lot of different types of delisting devices, and we use the results to develop our very own correlations. So all the correlations in MySep are proprietary to MySep that have been developed based on extensive R&D. I
All
think
right.
we can definitely discuss that in a separate occasion. Yeah.
All right. So there's a question from Mahdi. I'm not sure what is the question. Is basically say L by kind of LD ratio where
L over D.
yeah. So
Mhm.
I think this is kind of the rating. What you have.
Yeah.
Yeah.
Yeah, it could be a rating parameter, or it looks more like a sizing calculation. If you're doing a sizing exercise, yes, you can definitely specify all of this and size based on the criteria that Marty has defined. So yeah,
All right.
definitely doable.
Then next, Nika Dui, do MySep in HYSYS flowsheet can simulate inlet stream with surge flow. So in
Yeah,
relation with surge flow.
yeah. I'm thinking. Hi, Nika. Nice to see you here. I think if you're looking at a slug arrival or a search case, definitely it will be possible if you have a dynamic simulation model in HYSYS that is linked to a pipeline simulator. For sure, you can take a look at the slug arrival and the impact on separation by using a HYSYS dynamic model together with MySep engine. So that is doable. Don't know, Fauzi, if you want to add something to that.
Yes, yes. So I think for kind of a search, right? Search can be caused by it could be by your pipeline contour, right, where you have up and down, you have liquid accumulations, right. Then there's a periodic surge that definitely we can model it in HYSYS when that kind of a bulk of liquid comes into the separator, how much spike in the or how much the liquid level will increase, right. So this is something typically also will be is considered when you're doing your separator sizings also, right? Right.
Yeah, yeah.
Okay. Next, MySep, does MySep support finger slug catcher? I think it was there's a chat answer by uh,
Was there? But
does MySep support
oh, yeah, I see the question, Fauzi. You can't graphically represent a finger type slug catcher in MySep. So graphically, you cannot model that, but we have used MySep to take a look at the individual fingers. So that is something that you can do with the workaround.
okay, cool. All right. So for the calculation, does the it follow the fluid package defined by HYSYS? I guess. I mean, to me, I guess the correct me if I'm wrong, Avinash, but I guess the parameters imported in basically the parameters used in HYSYS. I mean, it's sorry in MySep is imported from process simulation, for example, HYSYS. So does that it relies on the process simulations uh,
Correct.
fluid package to predict the density, viscosity, whatever the parameters is used, right?
Correct. MySep doesn't have a thermo engine, so it relies on the HYSYS thermo engine.
Yeah. All right. So is MySep capable of simulating sloshing effect? I did see this YouTube from MySep, but I'll let Avinash explain. Sloshing
Yeah,
effect
yeah.
is, on floaters such as FPSO. Yeah.
So MySep does have a motion module, so you can actually look at sloshing effects within MySep.
All right. Okay. Okay, so this is maybe I will read and probably I will answer from Mohammed Yasser with due respects of detailed analysis solutions that MySep offers. Does Aspen complete own calculations and result produced by MySep? for client perspective, and engineering contractor would like to know on high level if MySep acceptance has been documented in form of certification. I think for I can't speak on behalf of Aspen, but I would say basically this is like add on to HYSYS or Husband HYSYS, right? So basically the integrations, right? I'm sure. I think MySep has its own kind of QA procedures, incorporating the research, the correlations, etc. Right. So it's a choice to the customer, right?
Yep, yep. And Yasir, I think your question is very much more focused on maybe the right question is what kind of validations have been done with MySep, like what I've explained before. We've done our very own lab tests. Secondly, it's been validated by our clients. It's being used by major operating companies and engineering contractors, and all of the feedbacks have been very positive. So the validation has been internally, externally by our clients. I think that is the most important validation that MySep could potentially get.
All right. Okay. Next, liquid separations. Can we specify what's in the what in the water oil and oil in water at the outlet? Does MySep can do the preliminary sizing? I think this is you have answered then.
Yep, yep. Hi, Sukrit. Nice seeing you here. For MySep, what it does is that you come up with the preliminary sizing and it actually tells you what is the water in oil or oil in water separation. So you have to do this iteratively. You come up with a size, then you start predicting what the performance is. If the performance is not meeting your specifications, then you go back and optimize things like in the piping or having plate back coalescers to improve liquid-liquid separation performance. So it's something that you have to do iteratively, not something that you can specify to the software.
All right. Yeah, I so good. Hope that's answer. Yep. Okay. All right. Next. Okay. So I think there are some questions related to other process simulations. I think we can ask. We can reply that separately, right? Then Maziar, the calculations are detailed and comprehensive, but can you let us know how the calculations and results verified? I think this is you touch also about the validation.
Yeah, 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 exactly. Mazia, there's actually more information on the validation done on MySep on our website. Perhaps after the session, I will send over some of the information to you.
All right. Okay. Next. Right. Sid. Okay. Can we have more detailed difference in doing calculations of carry in HYSYS and MySep? HYSYS come with the built-in correlations. Uh, yeah, I think this is I would say maybe something you can compare, right? I mean, then there's a built-in correlations in HYSYS, but definitely uh, there's a lot of more choices in MySep in terms of the different outlet device, inlet device, right? Okay.
And yeah,
Yep.
indeed this.
Avinash, you want to
Yeah,
add? Yep.
yeah, but I think yeah, certainly like what Fauzi had mentioned, I think MySep does pretty much more details with respect to the internals, and I think with respect to the drop process prediction conclusions as well. So there's more details in in MySep.
Yeah. Okay. All right. Once MySep is imported, can we do changes related to the internal size in HYSYS?
Very good question, Sid. So all of the changes with regards to the vessel has to be done within the MySep Studio environment. When you import it, it is pretty much a runtime license. So you cannot change the geometry of the vessels or any of the internals.
All right. Yeah. I think we are running a little bit more, but let's finish this. All right. So
Okay.
can use MySep inside EO flowsheet. That I
Hmm.
have not tested.
Me too. I have not tried that.
Yeah, so maybe we'll get back to you. I do
Okay.
have some time to test maybe today.
Okay. Cool. I'll be interested to know.
Yeah. Muhammad Yazek, if the task to convert two-phase separator to three-phase separator by retrofitting necessary, I believe myself a good tool to achieve this. Any comment?
Absolutely. I think in the case study that we've seen so far, what we've done is to sort of model an existing separator and evaluate the performance. But like in your case, when we're looking at retrofitting, MySep is also a good tool to do that. So MySep is very versatile. In the example we showed you is more like a debottlenecking case, but definitely it can be used for retrofitting.
All right. Okay, the recording, yes, it will be sent in the email after this. Basically, once the recording is available, you get the link to replay, right? Okay, MySep can support amine flash dump separator. It works with amine. I think it doesn't matter, right? Because
Yeah,
it's
yeah. It
liquid.
relies on the physical
Yeah, the physical, as long as the physical properties is generated, I think is it can do.
Absolutely. Absolutely, Isaac. So it does two-phase and three-phase separation as well. As long as you have the physical properties, MySep will give you a reasonable result.
HYSYS does have that thermodynamics engine to support amines, right? We have
Mhm.
chemical, acid gas, chemical solvent, and a few others to support that, right? Cyril George, any model available for separator design for green hydrogen electrolyzers process? Um,
Um,
I think my opinion for any separations, right? I mean the the basic principle or the first principle is the same, right? It's like, I mean the gravity, the difference in density, etc.
densities,
Right? So
exactly.
I think the fluid, again, as long the fluid does not really matter as long as we do have the properties of the gas, of the liquid, the light liquid, and the heavy liquid. Right?
Yeah, certainly. I think you've covered that pretty well, Fauzi. I think Cyril, it's great that you brought that up. We actually have taken a look at hydrogen separators, so that's definitely doable in myself.
All right. Okay, two more. Can myself HYSYS vendor inlet distribution like Schuppentutor, miselimeter, like SMS, York, supplied by Sulzer and Koglich?
Yeah, that's a good question, Amar. So what you have in MySep, like what I've demonstrated earlier, you have a range of inlet devices that you can select for, similarly for domestic devices. And what we have in MySep, we call them as benchmark internals. So there are certain parameters that you can alter and model internals from different vendors. So it is perfectly doable in MySep. So you can represent internals from different vendors.
All right. Okay, last one from Muhammad Yazir. For ellipsoidal and hemisphere head, wares are not yet supported by other correlation available in HYSYS. I believe my SEP wins among of other correlations in terms of details and accuracy. Okay, that's a statement. Okay.
Yeah, thank you for that, Yasir. Point noted.
And my SEP helps at best selections based on the area and costs of
For sure.
right?
For
Optimize.
sure, Omar. Yeah, for sure, Omar. I think that is something that you can definitely do with the sizing routine. So in MySep, you can evaluate a couple of different sizes with different configuration that would potentially yield in different vessel sizes. So all of that is perfectly doable within the MySep environment.
All right. Okay. I think that's about it. Sorry, Ajay. We will answer your question offline. I think we are kind of running time, right? So let me
Okay.
share my screen again. Right. Thank you so much for everybody times. Let me share before we go. All right.
Okay.
Yes. So thank you. And yeah. All right. Okay, this is just a reminder again. Don't forget you can download the handout if you haven't done so. In the email, I will also send out the PDF, the link to download the PDF handout. Right. Thank you so much. I think this is one of the most interactive or hot topics. A lot of questions.
A lot of
Thanks, Avinas, for spending your time and sharing your knowledge and
no,
also answering
yeah,
the questions. Right.
no. Thanks, Fauzi, for having me, and I hope the session today was interactive and useful for the rest. And thank you for all the questions. Appreciate it.
All
So
right.
yeah, thanks, Fauzi. Hope to see
Thank you.
you around.
See you.
Thank you, everyone.
Thank you, everyone.
Bye.